Hello, everybody. Thanks so much for joining today. We have Peter Titov, who is a solutions architect here at Elastic, and he's going to be presenting on visualizing COVID-19 data. We have a whole series of virtual meetups right now that we're promoting through the AMER virtual user group, so I'll link to that in the chat so that you can stay up to date on all of our virtual meetups. Or if you'd like to present, we can also talk about that as well. So without further ado, Peter, thanks so much for taking some time today to talk through this with all of us. I know there's been a lot of excitement around this topic, so I'm really excited to see the presentation today.
Thank you, Faith. Hey, everyone. How are you all doing? I hope you're all alive, well, and healthy, of course. I hope you guys are sitting down because you're about to get a really, really long PowerPoint. But basically what we're going to be going over, I'm not a big fan of PowerPoint. I don't like to kill people with them softly with all of my slides. So we have a pretty jam-packed agenda. Let's see if we can get through it all. But this session is designed to be very instructional in nature. So at the end of this, the intent is for you to be able to replicate the steps that I'm doing here at home and to get a better understanding of the COVID-19 data and how you can use this with other sets of data as well. So like I said, it's a pretty jam-packed agenda. We're going to go over the data set itself of the type of data that we're going to be pulling in, most notably being provided from Johns Hopkins University, as well as what's required from a Logstash side in order to get this up and running, as well as actually getting the data into Elastic. And for this instance, we're actually going to be using Elastic Cloud. So if you haven't created a trial yet, feel free to do so and get Logstash down locally, and feel free to come back with this video and get it up and running. Or if you have it down today, feel free to watch through with the steps and play along, as I like to say. In addition to that, we'll also be going over some customizing the visualizations on there and show you how to essentially use these as building blocks to facilitate other visualization building. And I like to think of them as Legos or building blocks, because with these little Legos and building blocks, you want to build a space shuttle, or maybe you want to build a castle or what have you, and we'll be building the dashboard with that. And of course, tying it all off with some Q&A. So, you ready for the PowerPoint, everyone? All right, it's already the end. So without further ado, let's get to the meat of everything. Now, I'm sure everyone has seen at some point this dashboard provided by Johns Hopkins. It gives us a nice summation of everything that's going on with the total confirmed deaths, confirmed cases, recovered aspects, etc., all broken out by country and by some regions as well. Now, there's a lot of different approaches that folks have taken to getting this data in, and I started working on one myself, and I've actually found a repo provided by our friends over at SciScale that have done actually a rather marvelous job at this approach. I'm using their pipeline to ingest that data. So I'm going to walk through some of these elements, and I'm going to show you how to get that up and running. So to give you an idea of the dashboard that gets created from this process, you can feel free to go to this link as well to pull down this information. In addition, they have their own GitHub repository where that information is all stored and what we'll be using for today's session. That, of course, can be found right here as well. And an easy way to pull it down, you can either download it directly, do a git clone, etc. And all of this information that's stored in here is essentially the index template mapping, what we're using to map the particular fields, as well as the dashboard and associated visualizations with there. In addition to some of the pipelines themselves. We're actually going to be using the daily reports because of the amount of data that's contained within there. We get much more information out of it. And there's some watches if you're interested in applying that if you want to be notified when a threshold reaches for either your particular country or your particular region. And everything's all set out through here. It gives you an explanation as to walking you through, but some folks and myself, I'm just as guilty as the next person. Maybe I don't feel like reading through all these and just using the experience gained from several years of using Elastic. I figured, hey, why not show folks how to do it directly? And like I was mentioning, the information contained within the SciScale GitHub is really just pulling down the information from the Johns Hopkins GitHub, which is nothing more than a series of CSVs stored in the daily reports. And what this pipeline is doing is pulling down each and every one of these CSVs, parsing out the data, normalizing it, and ingesting it into Elasticsearch. And if you leave it running, it'll automatically pull it down and update your index as needed. So without further ado, how do we get this data in is the big question. And for folks out there, if you're not familiar with a command line, I'm going to be doing a few little commands here, but just to give you a little bit of a walkthrough of what we're doing. So I've already pulled down the repository that Sesco provides, and I put it down directly within my Logstash directory. As you can see, it's all listed right here, my COVID-19 elk. If I were to do an ls within that directory, we can see all the particular materials that are needed. For instance, we have the COVID-19 dashboard, like I was mentioning, the index mapping, etc. Most importantly is this daily reports template.conf file. This is the actual pipeline itself that pulls down that information. And if we were to look at that information, well, I've actually already made a copy of that inside my config-d folder for where I'm going to tell Logstash to go ahead and pick it up and collect it from. So if I just do a simple cat conf-d Logstash, and I already have it within here, get an idea of the pipeline that was built for us. And this is actually a rather, in my opinion, elegant approach. And while it may seem kind of convoluted from the text that you see listed here, you'll notice that you'll have three basic components. You have an input, a filter, and an output. The input is basically just pulling down from GitHub and doing a check of whenever there's an update. And if there's an update, it automatically starts pulling down the information. In addition, down within our filter, we're not going to go through every line within here, but I just wanted to highlight some important aspects of it. There's some Ruby code in here where it's requiring various prerequisites, as well as creating various events and basically doing all the hard work and the normalization for us. And most importantly, it's actually performing some enrichment and calculating various ratios of death to confirmed, recovered to confirmed, and so on. And it's creating these events in line as the data is being ingested. And this is exceptionally helpful with many pipelines as well. In addition, as we go through, it lets us know as the hashes are stored, so when new updates are posted to the repository. In addition, we have all of the date parsing that we need to do and any mutation of the data or any sort of changes we need to make. So for example, country region, there's various names of the data that as it's grown throughout time. And it's very important to have a normalized data set. So for example, if you have countries that, for like the Macau special administrative region that's also tied to China, you might want to condense those into one particular region. That's just one example. In addition, you may have fields that are specifically tied to either just a latitude or just a longitude, but we may need to join these to form a geolocation field, or a geopoint as it's known as. And I'm going to get into a little bit more of that here in a minute, as well as perform some other mutations and modifications of the data. And as you can see, we're having it posted directly up into our Elastic Cloud. I've already created this instance, so feel free if you want to play along. If not, that's fine. I made one little line in there for simplicity's sake where I'm saying disable SSL certificate verification is for simplicity's sake, but that's essentially the intent of it. But before we can do any of that, we need to load that template file. So as we go back, let's take a look again at that COVID-19 elk folder, and more particularly, that index template. The index template is essentially what tells Cabana and Elasticsearch how to interpret that data. Remember a moment ago I was mentioning the location field where this is a geopoint. It's actually taking a lat long and merging that into that location field in and of itself. These other type components are telling us exactly what type of data is contained within a particular value. So for example, long would be a numeric type value. If it's a date, such as updated at, and so on. But with this all in play, now all I have to do is go into my cloud-based instance, which I have here. I've already stood this up. And if you notice, I have no other indices other than my system-based one for my ILM history. In addition, I have no template whatsoever. So in order for me to post that in there, all I have to do is go down to my DevTools over here. We can dismiss this. Now we're not going to do a get search for the first one. All we're going to do is simply copy and paste up until the very last character from here. This little play button is going to click to send the request to our cluster. We get our acknowledge true. And now that we know our template's loaded, we can simply come back to our index management and go to our index templates. And now we see that the COVID-19 live update template has been loaded. This means that once we start loading our data in, it's going to automatically use this template and map the fields as necessary for creating the index. And if we needed to make any changes to it or make any custom modifications, we can easily just go into the edit component and do it as such. The mappings field makes it exceptionally easy if you need to add a field or maybe you want to change the type of data that's coming in. You can easily do that here, but that's not necessary for this point. Now, prior to this, we also want to load in our sample data as well too, or excuse me, the various components or those dashboards that we wanted to load in. And we have all that information, fortunately, already stored within that I've pulled down. And we're going to just take this as a saved object. So let me show you the file that we're going to be tackling at this point, which is the Cabana 761 COVID-19 dashboard ND.json file. This is designed to work with version 761 or above. So if you're on any of those two versions, which are the most recent releases, you should be good to go. But from here, it's just a simple saved objects, go into Cabana, import, and I've already taken my folder here. All I have to do is drag my little ND.json file that I've already copied over, click import, and voila, my 13 objects have been successfully loaded. But what are these objects? We have the dashboard, we have our index pattern, we have maps and other associated visualizations already tied in. And while I'm still going to show you how to customize some of these visualizations from scratch and give you a quick walkthrough, it's great to use this as a starting point as well if you want to explore on your own. So now we've set up everything ready to get data in, but we haven't got any data in just yet. And this is actually what I like to think of as the nerdy fun part. So going back to here, we have our logstash instance. We know about our config file to load this data up. I've actually already saved the command in here, and I'm just going to kick off logstash quickly, specifying my particular template, which is right here. So I'm going to run logstash as an application. I'm going to say, hey, take this config file, which I already have preloaded. And it takes about a couple minutes or so for logstash to pick up, retrieve the data, normalize it, and ship it off to our cloud-based instance. And while this is running in the background, I have another instance of this data already loaded up. I wanted to take this opportunity to just do a quick walkthrough of Cabana to give you guys a little bit of a background in case you haven't had one already. And as you can see here, our logstash is already picking up our one config file that we specified. Starting to ship our data off, so we're good to go. And I know it takes about 2 minutes or so we got about 2 minutes to go through this on another cluster already stood up. Now in this other one, I already have the data loaded, COVID-19 live update, but if you notice, I'm only looking back at the last 15 minutes. Now, obviously, this instance has been going on for quite some time, not just in the last 15 minutes. And the very first thing I always like to do is expand my time window of when the events started. And we can do this a couple different ways. We can look at when this data set started, or we can just try and do it willy-nilly. But knowing that it started on the 22nd of 2020 of this year, we will just take our time window, and this is our start, and this is our stop time. So we're going to stop it for now, but for our start, we're going to go to an absolute. And quick little ways of pivoting around through here instead of having to click back until we actually get to January, just click on April, go to January, find our 22, and scroll right on up to quad 0 and update. And from here, we'll be able to see all the data as it's coming in. And you'll notice as COVID-19 has started to expand out, as the data was coming in, it wasn't completely, how to put it, very well characterized. There was more and more elements that were being added as there were more people that were becoming infected. And you can see at one point from March 22nd to about March 30th, they were using a standard format and then sort of changed it again. So taking that consideration, you can actually visualize of how the data was changing intrinsically. In addition, we also want to pay close attention to our various fields that are listed within here as well. So we have our timestamp field that obviously is based around the time of the event. But if you notice these little icons on the left-hand side, this is giving us an indication of what type of data is actually stored within here. With a B or a T being a type of text, a number sign being a numeric-based value, a last process being more of a date-based value, as you can see, similar to the timestamp. and most notably this location field. Now, you can't really visualize in the location field because this is a geopoint, or a combination of a latitude and longitude value. And all these are various pieces of information. If you notice within here, if we wanted to make our data resemble something similar to what we were witnessing, and let me pull one of the more recent aspects so we can see what that CSV would typically look like. So we get an idea of how it was structured with the FIPS code. They called it as admin2, the province, state, country, region. Maybe we wanted to view this information in its native form, but within Discover. If we wanted to do something along those natures, then all we would have to do is essentially add the field over here. Now, if we want to get an idea of the various values within here, we can simply just click on the field in question, and it'll give us a list of typically the top 5 values associated with it. Now, if I want to see this in a more structured form, I can simply do, let's find our province, state, country, region, confirmed, recovered, deaths, and I'm particularly fond of the active key as well, because that lets us know how many active cases there are, just doing some simple math essentially. And like so, we're able to actually get an easy view of the various pieces of information. And if I wanted to save this information, or maybe I want to use this as a save search for later on down the road, maybe in some machine learning jobs, we can easily do this as well too. So for example, if we wanted to keep this where we're looking for only confirmed pieces of information that are greater than or equal to 1, add those elements in. And since confirmed is on just about every single one of these, we're going to have the same types of results. Now, if we were to change this and maybe do a recovered, since our view is listed in here, we can now see anytime there's a recovered that's greater than 1, and have our view saved up accordingly. If I wanted to save this as a save search, simply recovered greater than or equal to 1. And quick little ways of saving what you've done or reusing it, you can simply just reapply the same type of filter if you're after the same type of data like we are here, with confirmed greater than 1. Save it. Obviously save it as a new search because we don't want to overwrite what we've just done. Confirmed greater than 1. And like so. Let's check on our Logstash instance, shall we? So we see that it failed to fetch for the 9th, and today is the 9th, and we may be wondering about that, and that's because the date itself hasn't been actually updated up yet. Typically, it gets posted around 8 p.m. Eastern time from what I've seen, so that's why you'll see the failed for the date component. But now that we know our date is in there, let's take a look-see at it now that it's freshly loaded. So we'll go back to our index management to make sure that everything is there. And voila, we now have a 35.2 megabyte file with 62,542 documents all inside our COVID-19 live update. One thing I like to do just for good measure is go to my index pattern, make sure it's nice and refreshed from there, making sure I have all my associated values. If you notice the field's 28, this is how Cabana is going to interpret the data as it's querying in Elasticsearch. From here, we should be good to go into Discover. And occasionally this happens from time to time. So all we have to do is simply add in COVID-19 live update, stick it around the timestamp. For good measure, I like to give a custom index name. So COVID-19 live update again. And then from here, we'll now be able to go look at our freshly loaded data, and it'll be identical from what we saw before. Again, last 15 minutes, nothing really there. So we'll do our same absolute to confirm that all our data is as it's expected. And voila, we now have all of our data loaded up within here. But what about that dashboard that we saw? How would we like to check that element out? If you notice down here on the left-hand side, there's a little arrow that expands out. So if you can't remember what the icons all stand for, easily expand this out and go directly to your dashboard from here. From dashboard, we have just our COVID-19 dashboard preloaded. And we'll automatically search back through the last 30 days. And we have all our data perfectly preloaded up within here. Now, what if we want to start building some of these visualizations ourselves? This is a great data set to get tried and true on, because it's one that I think every one of us can relate to. We're all impacted by it. We all understand the concepts of confirmed cases, people who unfortunately did not survive, and those who were able to recover. So if we wanted to build upon these visualizations, we can easily do that with Lens. And if you haven't had a chance to use Lens yet, I would highly recommend it. To get there, simply go to Visualize and create visualization. Two different ways. You can either click on the icon or on the giant blue button, and I like pressing buttons, so let's press the button. And from here, I always like to look at all of my data. So we'll go back to that absolute time of January 22nd at midnight. And right now we're not really visualizing anything, but we have all our fields over here to the left-hand side. We have our x-axes, y-axes, and how we want to break down our data. And since this is all time-related data, you guessed it, we're going to use the timestamp for the x-axis. But since we're not dividing by anything or implying a y-axis within here, we probably want to take the number of confirmed. And since this is a numeric value, we can just simply drag this and drop it over here. Now, out the gate, this is going to break it down by the minimum of confirmed, and that's not very helpful. As we can see, it's just a bunch of bars at this one point. But since it's a numeric value, there's some cool things that we can do with this. And I like to consider this the pirate approach. I'm going to do this all one-handed. So if you unfortunately lost your hand to an alligator like poor Captain Hook, you too could play along. So since it's a numeric value, all we have to do is apply what sort of mathematical approach we want to this. In this instance, we're going to change this to a sum because we want to sum up the number of confirmed cases. And like so, we can now get a much more visual representation of the confirmed cases. And yes, we know it's a sum, so let's make it a little bit easier to read and look at it in that sense. Now we can add additional y-axes in here, or we can add additional layers. And maybe that would be helpful, or maybe we want to see how it's broken down by a particular country and region. Notice the breakdown by field over here. All we have to do is drag and drop our country region keyword within here, and this is going to give us our top values. And this is only showing top 3. Maybe we want 5, or maybe we want 10. Simply click on the top values. You can either drag it up over here, or if you're really lazy like me, you can just actually scroll, if you have that on your mouse, up to 10. In order of direction, descending, we don't want to say the top values of keyword, we'll just say top 10 countries. Now this just gives us a count over time, seeing that some countries are staying rather level off, but maybe we want to see this in a more time or temporal based type of relationship. And what's cool about Lens is that it gives us various suggestions of how we want to view our data. Obviously our current view, but right here, this line chart is actually looking a little bit more interesting to me. The reason why I say that is because now we can get a time basis and a sum based around our countries as to how the confirmed cases are actually propagating throughout over time from the very beginning to the current. And we can see quite clearly here that unfortunately the US is way up at 129,000 confirmed cases, with other countries down below, Spain, then Italy, and so on. And if I wanted to add additional layers, I could do that here, but keep in mind of who's going to be viewing this information, who's going to be interpreting it. And maybe that might not be the best approach where you want to layer various elements on top. So we're going to actually remove this top 10 country breakdown. And from here, we're only going to keep track of the confirmed count. So I'm sure everyone on this call has heard about flattening the curve for that term, or maybe we want to see when those elements are starting to take into effect, or what does that look like compared to the recovered and death ratios, as an example. So this is where I like to think of it as sort of like we're all told to wash our hands, where one hand washes the other. One visualization visualizes the other in this sense as well too. So from here, I can actually add another layer on top of this. And again, x-axis with a timestamp, powered approach, still one hand. Drag my timestamp across. Maybe now and this time I want to look at the recovered counts. Again, just drag the recovered on over, but it's a minimum. So we'll change that to some. And because I don't like to have so many words in my labeling, we'll just say recovered. Maybe we can get an idea of the various deaths and how that's relating over time as well too. Simply click down below, add another layer, or one more visualization to wash yourself with. Deaths, and again, change that to some. Full disclosure, I am using two hands to type, so poor Captain Hook, you won't have it as easy. And voila, just like so, I'm able to create a simple visualization to visualize the various counts of confirmed, recovered, and deaths using Lens. What if I wanted to take it to another level? What if I wanted to start using maybe the time series visual builder with the various pieces of information I see here? Now, of course, I want to save this information and use this later on. I can easily do that as well. Save as a new Lens visualization, and we'll just call this COVID top counts Lens. Now we can use this in our dashboard later on. So if I were to go back to visualize and then go over to the time series visual builder, if I give it a single click, it's going to bring me back to this list here. Go back to my visualization. There's many others I could choose from, but I'm going to choose the TSVB or time series visual builder. As this is coming up, we're going to, of course, expand our time frame for absolute, because we only deal in absolutes like a good Sith would. And if you can't tell, I'm a big fan of using puns in the way I deliver speeches. So I hope you're picking up what I'm putting down. In addition to this, so now we have our time series visual builder. We're essentially just doing a count over all the fields here. But maybe this isn't exactly what I'm looking for. Maybe I want to build more of a visual type representation of a sum confirmed based off of my countries to make it a little bit more meaningful. And that's the aspect, that's where I'm going to start looking for the top N. With the top N component, and we'll wait for the visualization to come up, we can see that it's a count. And this isn't being very helpful because it's just doing a count over everything. So we're going to change this to a sum from our drop-down menu of our aggregation. We'll just simply pick our field, confirmed. We'll group by terms by our country region keyword, and we'll order by sum of confirmed. And sometimes the data likes to play hectic on me because we're still looking a little bit in the future. So we'll change that. There we go. So we'll put it to yesterday just to be on safe measure. And as you can see here, we now have a summed top end visualization of all of our top 10 countries in here. But what if we wanted to colorize this a little bit more instead of using just a green aspect around here? From here, we can go into our panel options. And down below is here where we have our style component. And here's our color rules. And if you notice, there's a set bar to, and it's clear at the moment, an if metric is. And what this is going to do is going to allow us to modify the color visualization based around particular values. And since we have the top 10, we'll say the top 3 we want to have red, the bottom 3 we want to have blue. So looking at the numbers, we see that anything above 113,000 is going to be our top 3, and anything below 62,000 is going to be our blue. So using our style down below, we'll set our bar and scroll down just a little bit here to red. If metric is greater than or equal to, and just for sanity's sake, above 113,000, so 25,000, pull out that first zero. And voila, we have the top three in red. But what about the bottom three? So we wouldn't have anything beneath 62,000 showcasing in here. The little plus sign on the side allows us to customize this visualization to additional layers as well. Scrolling down, and this time we're going to set our bar to, we'll take it purple. Purple is actually my favorite color. So, not that I don't like other colors, I just like purple a little bit more. And we said 62,000. There we go. And voila. Just like so, we were able to create a simple visualization as such. So we'll save this really quick. Top 10 confirmed, if I can spell correctly, confirmed countries. And now that we have this built, what if we want to change this around to maybe recovered or deaths? Now it's always best to we stand on the shoulders of those that came before us, and the same can be said about our data as well. The cool thing is that since we already have our data set loaded and everything's coming in, all we really have to do is change our fields we have listed within here. So within here, all we have to do, simply change it to deaths. It doesn't sound as simple, I know. In addition to that, we also want to change maybe the view. Maybe we don't really want to look at it in a top-end type of instance like this. So in this instance, maybe we'll go to metric. And now we get a sum of the various deaths, but having 10 of these isn't as effective. So we can change this to top 5. So summing by deaths, and what's cool about this is that it actually it does all of the work for me, and it makes visualizing and doing all these complex mathematical operations quite simple and so easy a pirate could do it. And again, if we wanted to customize some of the numbers, if we look over ahead for the sum of deaths, we'll say anything over 5,000 we want to have red. Going back to our panel options, color rules, not the background, and text, we just want to set our text to red. If my mouse wants to play nicely, here we go. Is greater than or equal to 5,000. And just like so, we're able to see, hey, that only China was under that number, so they do not get the red star. From here, we can save our visualization. And of course, save it as a new one, or we'll overwrite the other. Top 5. That's the country. So those were just some easy ways of creating some of the visualization aspects. But what if we wanted to take it a step further with maybe some machine learning components? Since we already have the data loaded in, we already have our data normalized, we know it's a numeric value, we can easily apply this as well too. So simply come over to the machine learning component. Create a job, and since there's none listed in here, we're going to take it from our index that we created, just a single metric. We use our full COVID-19 live data. Click next. Now here's the mathematician part, as I like to put it. I'm not a mathematician by the long of swords, but if you notice through here, you have various fields which are highlighted in bold for event rate, version key, active, and so on. But more importantly, there's various mathematical functions, and this is where the mathematician part comes in. If you need to apply a mean or a high mean to a particular field, you can apply this depending on what the data is. So in our case, we want to look for the sum of the confirmed cases to kind of get an idea of where these elements are going. And this is by no means a long shot scientific approach, but it's to showcase the ease of which you can apply these types of approaches for your types of data and not just coronavirus related. So from a sum confirmed, we get an idea of what the bucket span is. We can try and estimate it here. And since it is still a little bit sparse, since we know it only comes in once a day, we'll enable this component. Click Next. We'll give it a unique job ID. So this was forecast confirmed. If we wanted to add it to a particular group, and since there are none here, we'll just call this one COVID. Think of this as sort of like tagging with your various jobs. For some of the additional settings, I'm going to quickly touch on this, but we're not going to actually make any changes on here. If you wanted to tie in a particular custom URL, so if you wanted to pivot off of finding from machine learning, you can easily add that in there. Or if you want to omit events or to ignore events, you can add that in from a calendar perspective. But since our calendar is pretty booked with Corona, we're not going to ignore any of those, obviously. We're going to enable a monoplot, and this is going to help later on whenever we do our forecast. We don't really need a dedicated index because it's relatively small at this point. And from here, we just have to simply click Next. Bucket span gives a little warning like, hey, it's considering UTC days, it's not too bad, and our time range is long enough for the data in question. From here, it's just a simply matter of clicking Next. You see your data coming in, and create job. That's pretty quick. So from now, we're going to view our results. And again, like I said, powered approach to machine learning, one-handed. And before we go further in the forecasting, I just want to highlight a couple of things about the machine learning component. If you notice here where you have the actual and then what the typical and then the description. And if you notice, it's giving us an indicator if it was 2 times higher or 1.4 times lower compared to what was expected and then what was actually there and how it relates in a severity scale. Now, it's not so much that the numbers came in that rate. We're more interested in the forecasting component. In addition, you can also see this little faint blue line behind the scenes. That's essentially the predictable band of where machine learning is expecting the data to actually reside. And if you notice the trajectory of where confirmed cases are going, it's going in pretty much a straight line here. But machine learning is taking in all this information from the beginning to the end to factor this into its model. But notice the big blue button up at the top, and again, love pressing buttons. So let's press that forecast button. From here, if we wanted to forecast it out one day, it might not be as effective. So we'll do 14 for 2 weeks, and we'll see how close this can get. Now, keep in mind, this is taking into account whenever the counts for VAR are lower, so this will have an impact on our results. From here, we get an idea of a forecast model of the predictable sum of what was expected. And because our values were a little bit lower behind, it was actually showing a slight little decrease. That I'm going to hold that as true and tried, but it does give predictions going forward into the future as to what could potentially be additional confirmed elements. I know I'm touching on a bunch of subjects and topics from here. I want to just highlight quickly the ease of which to build the dashboard from those other aspects. Mike, I will answer your question here in a little bit. So going back to the dashboard component, if anyone here has ever seen the movie Zombieland, not the first one, but the second one, there's a thing called double tap. And if you double tap on the icon, it will actually bring you back to the list of the various elements. But since there's only one dashboard in here, this will bring us up to our one dashboard in question, which is the COVID-19 one. And if I wanted to build my own dashboard, again, these are nothing more than building blocks to add in to your own instance. So from here, dashboard, create our own, add an existing or new object to this one. We'll add an existing. There we go. Let's look at the full list. Of course, we want to use our lens visualization that we added in there. In addition, if we wanted to add other elements, we can do that as well too. So if we want to do our top 10 confirmed countries and top 5 deaths by countries, maybe if we wanted to add in the map as well, we can simply add in all these elements and then repurpose them as we see fit. So maybe we want to have a view it's a little bit more meaningful to us. You can easily do that as well. And remember, some of our visualizations like particular time. And voila, we were just able to easily add in just a couple visualizations and build a dashboard right out the gate using nothing but the tied in pipeline itself. And for Mike, can you show visualization log confirm cases daily rate with doubling days with error bands? Also, is there an export from the dashboard pirate approach into the code for other tools, e.g. display on web like Johns Hopkins University? Yes, you can export and share the various aspects of dashboards themselves. That's all done within the share command up in here. As for visualizing the log confirm cases daily rate with doubling days with error bands, I might need you to expand a little bit more on that, but so long as you're pulling in the data, you can visualize based off of the elements that you're pulling in. You might have to make some modification to some of your visualizations, but there should be no reason why you shouldn't be able to. If the data is there, you can query it. So, any other questions at all? Yes, it is more math. And again, I'm not a mathematician by a long shot. Any other questions all around pipelines for bringing this in? Any other challenges? It shouldn't be that hard. Happy to take the question afterwards if you would like to sync up. Feel free to reach out to me.
Somebody says, I'm new to Elastic. How do you configure log slash to ingest dynamic log files?
So for the dynamic log file component, that's really just going to be, depending on how you're going to get the data in, assuming that it's a simple file import or file input, excuse me, you would essentially just put the path to where the files would reside and put a splat, as I like to put it, or asterisk around the file name itself. When you say the dynamic aspect of it, do you mean the dynamic naming or the dynamic contents of the log files?
Time series file name.
Time series file name. Yeah, so in that aspect, you would essentially just put a splat within there. So if let's say your log files were called my log dash the date dot log, and it's obviously going to have a different date component, but you want to pull all those elements in. It would just be my log splat dot log, and then that would pull in the rest of those. No problem.
Yes, there will be a recording that's sent out afterwards to all attendees. So if you missed part of the presentation, it will come to you shortly, about a 24-hour return time on that.
And Mike, yes, you can ingest from more than one source to try and correlate. And depending on what the data source is, whether it's financial, maybe it's cell phone data, et cetera, depending on what you're trying to correlate it against, there could be many different approaches that you could take to it, whether it's from index aliasing to just throwing it all in the same index for proper mapping before it gets ingested in. So you could use it all on your own and what have you. Yeah, by all means. Yeah, it truly is an easy way to ingest data, and like I said, this is one from regardless of what your background is, whether you've been in IT all your life or you literally just started playing yesterday. Everyone can grasp these various concepts and apply them. Yeah, feel free. I'm happy to, talk to if you guys have any questions afterwards, or if you just want to hit me up on via email or Slack or what have you. You're welcome, Ben.
Awesome. Well, thank you again, Peter, for your time and for walking us all through it. Super interesting stuff. And folks, we will send out a recording of the presentation as well as a link to the virtual user group so that you can join for future virtual meetups as well. Oh, yes, there is also a Slack community mic. I can add that quickly in the chat before closing out. So if you just give me 1 second, I'll send the link.
And while Faith is doing that, I just want to give another shout out to the folks at SiteScale because they did a marvelous job of that pipeline, and I was greatly impressed. So I'm a tip of the virtual hat to them.
The link to join our community Slack is now in the chat, so we invite you all to join there for a discussion with other Elastic users across the world. Thank you, Mike, for the reminder. And thanks again, Peter, for the presentation.
You're quite welcome, and anytime, guys.
Awesome. All right. Thanks, everybody. Have a great day.
Thank you.
Bye, y'all.